for the value of m. We can rewrite this given equation as 3 to the power of m into parentheses 2 divided by 2, because 2 divided by 2 is the same thing as 1. So here we have 2 to the power of m in parentheses 2 divided by 2. This is equal to 65. We apply this rule because it is more convenient than squaring both sides, which is going to be a little bit complicated. So here we can rewrite this given equation as 3 to the power of m over 2, and we have this numerator here. So what I did is just to move this denominator down here, minus 2 to the power of m over 2 squared equals to 65. Now, what I'm going to do right here is let 3 to the power of m over 2 to be equals to x, and let 2 to the power of m over 2 to be equals to my y. So here, from the previous, so here we're going to have x squared minus y squared equals to 65. So from here, I can use what is called the difference of two squares. So here I'm going to have my x plus y, and here I'm going to have my x minus y equals to 65. Now, looking at this, 65 have so many factors. Part of the factors of 65, we have 1, we have 5, we have 13, and we have 65. Now, for us to do this, looking at x and y, it is very obvious that x is positive. Your x is greater than 0. And at the same time, our y is also greater than 0. Why? Because recall that 3 to the power of m over 2 is equals to the x, and 2 to the power of m over 2 is equals to our y. So no matter what, that means both of them are positive, okay, given that m is also positive. So from here, we can now say that our x plus y and x minus y is equals to 13 times 5. Then one can argue that why can't we use 65 and 1? It would be more appropriate to use 13 times 5 because here it is very obvious that the difference between x and y cannot be 1 based on these two conditions we have. And here, since x and y are both positive, then we can say that our x plus y is surely greater than our x minus y. That is, x plus y can be equals to 13, and our x minus y can be equals to 5. Now, solving simultaneously, we have our x plus y, which is equals to 13, and x minus y is equals to 5. Solving this using the elimination method, or let me say by adding both sides, then here we can have 2x, which is equals to 18. And from here, dividing both sides by coefficient of x, then we can say that x is equals to 9. Now, plug in x equals to 9 in, let me call this equation 2, and let me call this equation 3. In equation 2, then we can have 9 plus y is 13. By solving, my y is going to be equals to 4. Now, recall that our x is equals to 9 and our y is equals to 4. Now, going back, recall that we have 3 to the power of m over 2, which is equals to x. Also, 2 to the power of m over 2 is equals to y. Now, let's plug in. 3 to the power of m over 2 is now going to be, the value of x is 9. Or simultaneously, 2 to the power of m over 2, which is going to be 4. Now, equating the power, 3 to the power of m over 2, 9 is the same thing as 3 squared. And here we have 2m divided by 2 to be equals to 2 squared. Since the bases are equal, you can see on both occasions we can equate the power. And by equating the power on both sides, we have m over 2 is equals to 2. M over 2 is equals to 2. So here my m is equals to 4 for case 1, and also for case 2, my m is equals to 4. This shows m is equals to 4. Now let's check. The question given to us is 3 to the power of m minus 2 to the power of m equals to 65. So 3 to the power of 4 minus 2 to the power of 4, which is going to be 81 minus 16. And this surely is going to be 65. That means verily m is equals to 4. Thank you very much for watching. See you next time. Bye.